So now let's move on to qualitative maps, or maps that are using a level of measurement to map, or the level of measurement used is categories. And you need to remember that categorical data will usually be seen in the attribute table as text, but it can be a number that is left justified so it acts as text, and sadly sometimes it can be a number that's right justified that's entered incorrectly. So you really need to know your data. So again, always whenever you add a data layer, take a look at the data on the map first, see where it is, what kind of area you're covering, what kind of data it is. Is it vector? Is it raster? You should know that when you add it because it has different symbols to start with. But then check your attribute table. Again, so we've got the FID, the shape of this data that I'm showing is a polygon. I have nominal data, which is the name of each city. There's nominal data for the name of each state that the city resides in. Then I have categorical data showing the regions. This is entered as text. I have temperature data, which is interval, and it's entered as a number. It's right justified. I have crime rate or crime ranking. Again, this is ordinal data. It's entered as text, so I wouldn't be able to add these together, and I wouldn't want to. And then the population data is a number, and the average age is a number. Remember, when you see something that is average, it's already been normalized, so it's not a field you could do anything with. So the only data in this map that I could use to make a qualitative map or a categorical map would be region. And if we go back to the example, I used the type of volcano and mapped them so each volcano was added to one of these bins or one of these categories, and each was given a separate color. And that's one of the differences between a Choropleth map, when you're wanting to use a gradient of colors or hue so that you can show that difference. With categorical maps, you do not want to use a gradient of colors. You want each color to be distinct so that there's no confusion about what category or type that data is in. So with qualitative difference or qualitative data, you want to be able to show the difference of the quality. You don't want to show the magnitude, but you want to show how they are different in type, so that you can use for a point, you can actually use a little symbol. There's a mine symbol or a square for a house, or you can even have geometric data that shows different symbology for houses. I think some people for school data use the little school flag, and some people use the little three-dimensional pictograph for schools. The live tree and the dead tree, I love that. Just the way it's shaped or the orientation of the feature in the label would make a difference. You can use color again to indicate the different qualities. A live tree, hopefully you would use green, and a dead tree brown. Again, look at the lines. Dotted lines versus solid lines versus dashed lines, or just use the pattern. Different patterns could indicate different qualities. Now, when we looked at qualitative maps with patterns, you saw the intensity of the pattern from big checks to little checks to very small checks. In this map, for qualitative data, the pattern, the distance between those lines is the same. It's just the orientation that is different. And again, you could use colors to differentiate between borders. Same with area. So you really need to know what is the data that you're mapping. Are you making a qualitative or a quantitative map? And then that generates your the type of colors that you'll use and the type of symbology that you'll use. One of the reasons that categories and nominal fields are helpful is that you can use those fields to select or to do information queries. So we're going to do some queries which is just kind of asking questions about the data or trying to create a subset of the data. And so we're going to be using Boolean logic operators such as equal to, greater than, or less than. And ArcGIS, like most SQL query operations, require very special syntax or the way that the statements are entered. So if I wanted to know how many states there are in the Northeast region, I could do a query, say, show me all the states where their region type is Northeast. Now, I can use queries for ratio data as well, and interval data and ranking. I could say, show me all of the cities with a population greater than or a population equal to. So this isn't just a task that we're using for qualitative data, but it is a task that you will be using on this qualitative lab. So this is the map showing the data from the vegetation field. Again, I had a qualitative map that was based on the type of ownership. Now, in this data set, in this feature, there are 2,053 polygons, and each polygon has all of this information in the attribute table. It tells me what is the ownership, who's the cover type, what is the density, on and on and on. So if I wanted to find out how many polygons there are in private data, I could use an SQL query to easily do that. Now, you might be able to sort and then count them, but that's kind of, it's fine if you don't have very many records. But if you have a lot of records, that gets pretty onerous and it's probably not as accurate. So luckily, using an SQL query for that makes the task really easy. So starting with ArcMap and looking in the table of contents and clicking that field. So let's say I have a feature class or a shapefile called vegetation, and I want to run a query on that attribute table. I would start in the table of contents and I would choose the attribute link, and then the method is to create a new selection. Now, sometimes I can create a selection from a selection. So I could select all of the private landowners, and then from that selection, select only those polygons with a certain cover type. But we're going to start with simple queries. So I'm going to select here from the field. So that's the field type I want is owner. And then I want where the owner is equal to the term private, because that's the value. So when I click on Get Unique Values, I see my options. So if I choose double-click cover type, single-click equals, and then choose Get Unique Values, it lists all of my options. And then I can double-click private. Now, so my statement actually is select from vegetation, so vegetation is my shapefile, where the owner field is equal to private. And what you should notice is that private is text, and text is in single quotes in ArcMap. And so it's really helpful to remember to double click, then single click, and then double click again. The other thing that is really useful is to do as much of your SQL statement using the tool rather than typing it, because sometimes I can type in equal from my keyboard and the program will not see it. So there's my statement, and I choose apply, and then what I would see in my attribute table is that 165 records out of the 2,000 total records, the star means there's a few more than that, out of those 2,000 records were selected. And the selection is these polygons that are featured in cyan. So that is a really helpful tool. I can just kind of do a lot of queries on my data and get some information about how many Forest Service polygons there are. I could find out how many, whatever this value, how many of those Cs are private and how many Cs are Forest Service. So not all of your ArcGIS work ends in a map. A lot of it is analyzing your data and creating reports based on your data. Two other cool skills in ArcGIS is the summarize skill. So one way to get an overall count is to right-click the owner field and choose to summarize, and that process creates its own separate table. And what I get back out of this is that there are two types of owners in this data set. One is NSF, National Forest Service, and the other is PVT, private. And of the 2,000 plus records, 1,888 polygons or records are for the Forest Service, belong to the Forest Service, and 165 records belong to the private sector. And just so that you know, sum output is a really bad name for a table. And I just flew through this and didn't pay attention to that. When you generate a table, it should have a name such as Vegetation Owner Table or something like that, so you know when you end up with a list of 7 sum output tables, you'll know which one it is. So that's a good example of a bad example. The other very cool option in ArcGIS is the statistics button, or the statistics tool or function. So let's say that I'm looking at some numeric data, and this is ratio data for the, I think it's the % crown cover, and I want to know what is the total crown cover for this entire data set that I have. So I can right click and choose statistics, and it spits out this little interactive, or this little view window, and it tells me that, okay, there are 2,053 records or polygons. The lowest value in any of the polygons is 0, so that there is a crown cover of 0 in some of these polygons. I don't know how many. The maximum value is 95, and then the average crown cover for all of the polygons is 46.6, blah, blah, blah. And it gives me the standard deviation, and it also gives me the total. So it adds this column of numbers up. So for this example, probably the % crown cover sum is pretty meaningless because you're adding up percents of each polygon. But this would be useful if I wanted to know the total area in forests. Which is exactly what I have in the next slide. I guess I forgot to take that other slide out. So here I have right-clicked the shape _1 area. I right-click this, and I choose to do statistics. And for this data set, there are 165 polygons. And so what I did with this example is I chose from my selection earlier. So I selected 165 private ownership polygons. And from that selection, I did the statistics. So this is only adding up the area for the private polygons, or privately owned polygons. So again, I'm going to right-click this field and choose the statistics, and it will tell me that, okay, I've got 165 polygons selected, so that's good. The polygon that has the smallest area is 4923. The largest polygon area is listed below that. The total area in private land is given here. And then in this example, the mean and the standard deviation probably aren't useful information. But I might want to know in this region how much of this land is privately owned. So a lot of very helpful statistics here. So finally, another word of caution about file names. Do not put spaces in your file names, not in your MXD, not in your folder, not in your flash drive. It used to be really critical. Now it is less critical, but it will still show up sometimes that ArcMap will not be able to find data on a flash drive that has a space in it. And I see this more often when we're working with raster data. Do not use any special characters other than the underscore. You can't start a file name, and this used to be true. I know you can't start a field name with a number, and it used to be that you couldn't name a file with a number, so I don't do either. That may have changed, but it's just a good convention. So if I want to do 2000 population field, I do pop underscore 2000, and you probably don't even need the underscore. In raster data, the length is critical. You can't have long file names, and it used to be true with it's true with your field names. It will truncate your field names, so sometimes you have to keep a data file of what those short field names mean. So if I wanted to do a field called crown cove, I probably somewhere it says crown cove equals % of crown cover of fir trees. I need to have more information, but I can't put all of that in my field name. Let's see. For the rest of the term, it's going to be really important that you keep a journal or a process summary that tracks the data that you create, where you put them, and what you name them. And if you have the data in the field itself can have a space, and that's one thing that often confused people. Let me go back to this one. I could have the word north space west in the actual record. It just can't be in the field name.